So now, I figured I would make a video for those basically completely new to electronics. So, you want to start building circuits pretty quickly. And typically, you do that on these prototype breadboards. You can just call it a breadboard. And you plug components into the board. You do so though, so that they connect together. We'll come to that. Now, when it comes to powering the circuit, you always have to have power. You can use batteries. There's all kinds of options, but generally, especially when you're brand new, it's good to just get a power supply. So these are banana plugs right there. One plugs into positive, one into negative. You should use red for positive, black for negative right there. You can adjust the voltage and the maximum current that it provides. So that's very important when you're beginning, because you miswire something, you could have a short circuit. A direct connection from positive to negative right there. Very bad for batteries. Not so bad for a power supply. If you limit current, then it's just going to set the current. This has short circuit protection. Right now the output's on, and if I touch them together, the output turns off. That's short circuit protection. But even if it doesn't turn off, it'll limit how much current flows. Keeps the current low because I only have 25 milliamps there, 0.025 amps, same as 25 milliamps. Very low current. High current, you'll get a big spark, maybe metal will melt together. All kinds of bad things can happen. So you can keep the current low. When it comes to that 25 milliamps of current, I could lower it to red LEDs, or these indicator LEDs I should say, regardless of color. If they look like this, they generally have a maximum of 20 milliamps of current. They're going to be really, that can flow through them. They're going to be really bright at 20 milliamps of current. These red ones might be really good at 10 milliamps of current. You don't want to go for the maximum. You want to basically go for as low as is useful. 10 milliamps is probably just fine. And you control, when you got a certain amount of voltage, how much current is going through the LED with a resistor. This is a 220 ohm resistor. We will connect it in series. So the current from the power supply, the voltage pushes it, but we'll have to push it through these two components right there. And the red LED makes you lose a little bit of voltage when it comes to the power going through the circuit. But otherwise, the resistor value sets the current right there. So a higher value resistor, you'll have less current because there's more resistance. Lower value resistor, you'll have more current because it's not providing as much resistance. That's the relationship between voltage and current. Very important to keep in mind when you're building circuits. Now we also have a way to, we got to connect, these are 5 across when it comes to these rows. Each one of these is separate right there, but across there, the 5, they're connected. There's this gap in the middle. These 5 over there are connected. The 5 below them are connected, and so on right there. Usually you put power on these longer ones there. So there is a gap, but they're connected all down. When I say they're connected, all the ones next to blue are connected to each other. And then some boards go like halfway. But all the boards I have, it goes all the way to the bottom. And then same with the red there. All these holes next to the red are connected to each other. So if you plug something in there, I'm talking about next to the red wire right there, any one of those holes, and then you plug something down there, those two spots are electrically connected right there. Current won't have any resistance going through. So these are header pins. They are often long on one side, short on the other, and I think these came loose or something. If I push on them, they'll slide through. I don't think they were doing that before, but they were really uneven. I tried to even them as good as I can. So this shorter side right there, it's still long enough for alligator clips to clip to them to get a really good connection right there. As I said before, all of the red right there are connected together. So both of these pins are going to the same connection right there. And this is a cheap board, but it seems to be making pretty decent connections. These resistors I got are really cheap, and so they're extra thin. sometimes the board doesn't really hold them, but it's doing well. So just be aware that if you get cheap boards, they may not hold the components terribly well, but this one's not doing too bad. So yeah, we plugged that in there, and now we got positive power. Once this is on, remember we shorted it on purpose, that automatically turned it off, a protection. So we got all of the red connected to the positive right there. Once we apply power, and instead of putting it to the alligator clip first we can put the pins in there, and if I want to, I can take the negative side of the power supply. So power has to have, when you're doing basic circuits, they have a positive side and a negative side. Usually you consider this 0 volts. We got 5 volts at the power supply. Black is usually considered 0 volts. And then red, since we got this set to 5, the positive is considered 5 volts. There's a 5 volt difference, and we put the load between those 2 points. So to do that, we have what is called a jumper cable. So it's a cable because it's fixed sized right there. That's generally what a jumper cable is, and I'm going to show you a jumper wire. I got one off to the side over there, and so we got a jumper wire. So what we could do, they're good for going distances and at weird angles and everything. This kind of has a limit to where it'll reach. We got positive there. Let's say we don't just want this red side right there to just be the only positive option. We also want this side. We can just take a jumper wire right there and bridge the gap if we really want to. So that's the jumper wire, male to male. There's also female versions, but usually when you buy breadboards, if they come with the wires, you get probably just male, but maybe you'll get male, female. Females, these holes are the female spots. So sometimes there's something similar on the wires. So we got all the positive up there, the negative there, or jumper there. We're going to take the LED. So the long lead, the anode needs to go towards the more positive side. It's a type of diode. It has to be inserted into the circuit the right way for it to light up. So short side right there, because we didn't cut them, and sometimes it's shaved on the short side right there, has to be more negative. Diodes conduct in one direction pretty easily. They drop a little bit of voltage, but they block voltage in the opposite direction. Rectifier diodes drop a lot of voltage. LEDs, I think when you get like around 12 volts or something, then you can break down where it will conduct and it'll ruin the LED. But 5 volts, we can put it in backwards, doesn't matter. But here we have it forward bias. Anode will be more positive once we add the resistor. So we take the resistor there, and it's good to have the power off while you're wiring it up. So the LED is not going to turn on. Again, we're using 220 ohm resistance. That's going to get us a little less than like 15 milliamps of current. We got 5 volts at the supply. Red LEDs dropping about 2 of those volts, about 3 volts across the 220 ohm resistor. So that sets the current, and there is kind of a loose connection over there. So we may have a little less current. Again, these are cheap resistors right there. They got thin leads. This is a cheap board, and not all these slots hold tightly. So let's try a different slot right there. Seems like some slots are doing better than others, but nope, this supply is just kind of loose. But in case, this is probably good enough. I have a higher quality board next to this if we don't. So yeah, we got about 11 milliamps of current. This isn't as accurate as measuring with the multimeter either. And there you can see, yeah, if we get a little bit better connection, we get a little bit more current. Something to be aware of, but for the most part, you can see we got the lighted LED, and in person, it's actually brighter than what you see on camera. I think it's not a perfect match, but yeah, I think that's kind of closer to what it looks like in person right there. The camera picks up light levels differently than the eye. I adjust to the light level a little bit better, in my opinion. LEDs look better in person than on camera. They kind of look like a fireball more on camera, and they look a little bit more like a light in person. Hopefully that makes sense. But in any case, if you're just starting off in electronics, usually there's like schematics, but people also show you how to build these circuits on, you know, just in their videos, doing a step-by-step build. And so, you know, you should be practicing building the circuits as you learn them. Again, usually I have a schematic diagram, and usually I just have the circuit built. I don't build it step by step. So this is just step by step there. Doing this step by step takes time, and once it doesn't take you that long to get good at building circuits. So there's no point making tons of videos where it's all step by step build. Although when you're first building circuits, it will be helpful. Now, this power supply, again, you can see how much current it says is flowing. Again, it's not as accurate as a multimeter, and but it's, you know, it's relatively close, like 1 or 2 milliamps off. Again, this is 1 amp right there. A milliamp is 1/1000th of an amp, so that's 1 milliamp right there, but also 10 right there for a total of 11 milliamps of current. And when you do the math for Ohm's law, you do it in amps, but then you convert it to milliamps. So even though this says amps, it's doing the formula in amps. I'm saying 11 milliamps because I converted it. Hopefully that makes sense. So we got the 5 volts there. Now, another thing with the power supply. We are setting a voltage. Since the load doesn't need this much current, the output is outputting a voltage. The current is being limited by the load. Instead, we can limit current. So like you do this when you're charging a battery or something. You want to put a certain amount of current into it, and because that's how they charge. You add current to them, they charge. But you want to limit how fast. You know, you would do a lot more than 5 milliamps of current. But we're just doing this for demonstration right there. So what is this doing now? So you can see it's outputting, it says 6 milliamps. It's a little bit higher than what it says there. Which is a little bit surprising, but it's only 1 milliamp, no big deal. So what I gotta do, I gotta hit this button. There we go. Now that's not blinking anymore when I press this, because this button was alternating between those two up there. Now when I press this button, it's gonna alternate what you see on the display there. You can see the voltage that it's outputting. So in order to not provide more current, because the more voltage across the resistor, the more current you're gonna have. Therefore, the less voltage you provide, the less current there's going to be. So that is one way to protect circuits. So again, this is only going to output 5 milliamps of current, but if you think you wired this properly and it's not being powered, maybe you accidentally short-circuited the power supply. Now you can see the output is on, it's providing power. If you short circuit it, even though you have current limited, with this particular power supply, it will turn off. So be aware of that. Other current sources, they provide a certain amount of current. You can short them. They will just provide that current without turning off. But as far as I know, almost all power supplies like this is a portable, but it's, you know, similar to a bench power supply. Usually there's bigger ones. This one fits on camera. Probably the bigger one's better. Bigger one's definitely cheaper for how much power you can get out of it and stuff. I bought this mostly for making videos, but I use it for all kinds of other stuff too. It's pretty useful, and it's portable. If that is something that is more useful to you than a larger one, then go ahead, spend the extra money on a portable one. But in any case, instead of trying to find other options, you're probably just best off buying a power supply as cheap as possible. That's kind of similar to this, where you can set the voltage and the maximum current. Or if you have something else going on, you set the amount of current and the maximum voltage that it can provide. We're not going to go into detail on that. But in any case, I rambled on pretty long because I meant this for absolute beginners right there. So if you're just starting out, hopefully this is helpful in getting you to building your first circuit right there. There's a lot of stuff to kind of explain, but it's all very simple. Once you understand it, then you're going to understand it for pretty much the rest of your life, unless you don't look at electronics at all for years or something. But as long as you keep fiddling with them, the basics don't go away. You know, it may take a little bit to learn them, but then they're really stuck in your head unless you don't think about them at all for a really long time. Hopefully that makes sense. But in any case, that's it. Thanks for watching. Make sure you check out one of the other videos I'm posting on the screen and check out the links down below. They all help out a lot. I'll see you in the next video.